So in a previous video on graph and table questions or command of evidence textual questions, I emphasized the idea that a correct answer on these questions needs to be both relevant and accurate, but we want to focus first and foremost on relevance. Why is that? Because relevance is easier and quicker to check than accuracy. If you're checking accuracy, you've got to go and compare the answer choice to the graph, and that takes time, and even after doing that, you still don't necessarily know if it's correct because you have to think about whether it's relevant. Okay, and this is going to be particularly important when we get into more complex questions like this one, which is modeled on a question that appears on Blue Book Test 6, the nitrogen deposition question, if you've encountered that one before, but also this first example that we'll look at, which is more of a medium level example, and it is based on one from the question bank. And so let's just go ahead and get into it. And that means starting with the prompt. So which choice best describes data from the graph that supports the student's conclusion? So we'll read the passage, paying special attention to the variables involved in that conclusion. It says, to study how grammar and spelling affect the perceived quality of online customer reviews, researchers presented participants with 3 versions of a negative review for the same product. One with no grammar or spelling errors, one with a few minor errors, and one with frequent noticeable errors. A student reviewing the data concludes that while a few minor mistakes don't reduce readers' perception of a review's helpfulness, extensive errors do. And so in this case, what is relevant? Well, the student again concludes that minor mistakes don't reduce perception of a review's helpfulness, extensive errors do. If we look at the graph, if we zoom in on it, we really do need to zoom in given how small the fonts are, we see that we've got 2 bars for each of the 3 conditions. One of them is helpfulness of review, the other one is attitude toward product. And notice here that there's nothing about the attitude toward the product in the conclusion itself. In other words, the conclusion only has to do with the perception of the review's helpfulness, not the attitude toward the product. And so that means that these bars are not going to be relevant. But perhaps more importantly, it also means that any answer choice that mentions the attitude toward the product is going to be incorrect. And so if we scan through the answer choices, going from bottom to top here, product ratings, well, that has to do with attitude toward the product. We can get rid of D. C also talks about rating the product, so that's not relevant. And then A also talks about rating the reviewed product. Okay, and so given that we're only focusing on the helpfulness of the review, it really needs to be answer choice B, but let's just double check. So participants who read the review with frequent errors gave lower helpfulness ratings than did participants who read the error-free or minimally flawed reviews. And so that does check out. But I would say in terms of checking for accuracy, that's something we do to confirm that we have the right answer after we've found the answer choice that is relevant and or eliminated the 3 that aren't relevant. And so a little more basic example. The next one is going to be a little bit more complex. Okay, so soil salinity, the concentration of dissolved salts in soil, often increases in response to climate warming, especially in arid or very dry regions where evaporation exceeds precipitation. Rising salinity can harm plant growth, reduce agricultural yields, and degrade soil. So rising salinity is a bad thing. Okay, to evaluate mitigation strategies, basically strategies for mitigating or cutting down on this potential problem, researchers compared traditional irrigation with a newer precision irrigation method under 3 simulated climate conditions: current, moderately warmer, and extremely warmer. They measured average soil salinity after one growing season. Examining the results, a student concludes that precision irrigation can more than offset the effects of moderate climate change on salinity, but becomes less effective under extreme warming. And so I'm going to express this in terms of some inequalities here. Okay, so we've got precision irrigation under moderate climate change, Our graph is showing soil salinity here. So if we can offset the effects, that means that precision irrigation under moderate climate change is going to result in less salinity, less salty soil than what we would find with traditional irrigation under the current climate, under current climate conditions. To say that it can more than offset the change, what does that mean? It means as we go from the current climate condition to moderate climate change, we would expect, if we just stuck to traditional irrigation, we would expect the salinity to increase. But to say that it can more than offset it means this is going to be lower. But it says here it becomes less effective under extreme warming. This is a little tough because, what are we trying to compare here? I think what we want to say here is that precision irrigation under extreme climate change would result in higher salinity than what we would find using traditional irrigation under the current climate. I don't know how we would expect that to relate to that, but I think the important thing here is we need to compare this to that and this to that. And so out of the 6 bars here, only 3 of them are relevant. Precision irrigation, we got to really zoom in there. Precision irrigation under moderate change. We're comparing that to traditional irrigation under the current climate conditions, but we also need to take into account precision irrigation under extreme change. Okay, so we're not comparing this to that. We're not comparing this to that. We're comparing these 3 things, and so our answer choice needs to reflect that. And so let's look at the answer choices. So so we'll go to the answer choices here and focus on the categories, the conditions that are being compared. And let's start with D and work our way upwards. So salinity under precision irrigation with current conditions. So we can already eliminate D. Why is that? Precision irrigation with current conditions, that's not one of our 3 categories here. So right away, even if that's accurate, it's not going to be relevant, so we can cross that out. What about the end? The latter is lower than traditional irrigation with extreme warming. Well, we're also not concerned with traditional irrigation with extreme warming. So that has 2 things that are wrong with it. What about C? Salinity under precision irrigation with moderate warming is lower than under traditional irrigation with moderate warming. No. Traditional irrigation with moderate warming, that's not one of the categories, so we can eliminate that. Okay, B, salinity under traditional irrigation with current climate conditions is lower than under traditional irrigation with moderate warming. Nope. Traditional irrigation with moderate warming, not one of the conditions. So we can eliminate B, C, and D without even checking the accuracy because each of them brings in a category or condition that is not relevant to the conclusion. A had better be correct, but let's just go ahead and read it to make sure. So salinity under precision irrigation with moderate warming, precision irrigation, moderate climate change, is lower than under traditional irrigation in current conditions, but the latter, this, is lower than salinity under precision irrigation with extreme warming. And so, yes, that is accurate. This is lower than that, but this is lower than that. And that's just sort of the icing on top. Again, we do want to make sure that it's accurate, but we start with the relevance. Again, for the reason I already stated, but just to reiterate it, accuracy doesn't matter if something is irrelevant, and accuracy takes longer to check. So putting a little more effort in on the front end to make sure that you understand what is relevant is going to save you a whole lot of time on the back end, because once you recognize that something is irrelevant, you don't need to check for accuracy, and that's exactly what we get here. All 3 of the wrong answers are in some sense irrelevant, include irrelevant categories, and so we can eliminate all of them on that basis alone.